Hello and welcome to my lecture on global warming. In this lecture I'm going to explain the problem of global warming, and then I'm going to talk a little bit about climate skeptics, and then I'm going to talk about 6 philosophical questions that we should think about that have to do with global warming. Now this is a graph showing how the climate has changed over geologic time. As you can see, the climate used to be a lot warmer. I got this graph from Wikipedia. It used to be a lot warmer than it is today, but that was millions of years ago before there were any humans. Human beings have not previously existed in such a warm climate as we have today. What we see is that since about the 19th century, the Earth has been getting warmer on average. Now, the warming has been, it doesn't seem like that much to us, but it's been about 1 degree Celsius or about 1.8 degrees Fahrenheit since pre-industrial times, meaning around 1750. So the warming basically started around the Industrial Revolution time, but it has accelerated since the 1970s. So since the 1970s, it's been warming at about 0.3 degrees Fahrenheit per decade. Okay, this is another graph which shows how the average temperatures are thought to have changed during about the last 12,000 years. And you can see there is significant variation, but you can also see that there was a recent uptick in average temperatures, so that around 2016 it's much warmer than it has been for most of the last several thousand years. Okay, this is another graph which shows the last 2,000 years. And what you can see is that on this time scale, there's been a significant rise in temperature in the last about 150 years. And so that it's much warmer now than it was for the previous 2,000 years. Okay, now what could cause this? There are a lot of factors that affect the climate and the average Earth's temperature in particular. So the amount of radiation coming from the sun. There are changes in the Earth's orbit. This is largely why the temperature has varied over geologic time. So the Earth's orbit might move a little bit, or the eccentricity of the orbit might change, or the orientation of the poles might change a little bit. There's volcanic activity, which can affect the climate, and there's vegetation and the amount of vegetation on the Earth that can affect the climate as well. But these are not the things that we're most interested in right now. The cause of climate change that we're most interested in right now is greenhouse gases. So these are a kind of gas that trap a portion of the radiation that would otherwise escape from the Earth into space. So radiation comes down from the sun, it goes into the Earth. The Earth emits a certain amount of radiation, especially infrared radiation, and most of that radiation escapes into space. But greenhouse gases reflect some of that radiation back down to Earth, and that results in there being a higher equilibrium temperature for the Earth. Now, most gases are not greenhouse gases, so the Earth's atmosphere is mostly composed of nitrogen, which is not a greenhouse gas, so it doesn't trap the infrared radiation, and then followed by oxygen and argon. None of those are greenhouse gases, but there are a small amount of greenhouse gases in the atmosphere, especially water vapor, CO2, methane, and nitrous oxide in that order, in the order of how much greenhouse effect they cause. So the main natural greenhouse gas is water. But again, that's not really what we're most concerned about right now, because that's not the main thing that has changed in recent times that has led to a higher equilibrium temperature for the Earth. So the thing that we most care about is the human contributions to the greenhouse effect. So that is what appears to have changed in the past 150 years, the human contribution to greenhouse gases. In particular, carbon dioxide has increased since the Industrial Revolution. This is mainly due to human beings burning fossil fuels, so especially coal and oil. And that releases CO2, which traps some of the radiation in the Earth's atmosphere. Okay, the second major anthropogenic greenhouse gas, that's human-created greenhouse gases. The second main one is methane, which is thought to contribute about 20% of the man-made greenhouse effect. And that is mainly due to animal agriculture, and that is especially the about 1.5 billion cows that human beings are raising to eat them and take their milk. And the digestive system of these cows releases methane into the atmosphere, so that's a significant contributor. Okay, now according to the climate models that people are using, it's expected that there's going to be a warming of between half a degree and 3.1 degrees Fahrenheit by the year 2100 in a moderate scenario. We don't really know, and you can see that there's a wide range of estimates from different models. And there's also a lot of uncertainty about how we human beings are going to respond. And there's also uncertainty just about what will happen even if you fix assumptions about our response, okay? But it is generally thought that the Earth is going to continue getting warmer. Now, what are the negative effects of this? So first of all, some species are probably going to become extinct as a result of the warming. Some species maybe are not doing so great, and if it gets a little bit warmer, maybe that will be enough to tip them over into extinction. The sea level is thought to be likely to rise, and this could impact coastal cities. So we don't know how much it will rise, but some estimates say up to 3 feet. Or 110 centimeters. We might see some crop failures because, of course, the temperature affects how suitable an area is for growing crops, and so places that are currently suitable may become unsuitable due to being too warm. Also, there are some infectious diseases that spread more in warmer climates. So some people are probably going to die from that. And if you combine all of these things, the World Health Organization estimates that by the middle of the century, there are probably going to be around 500,000 deaths per year due to global warming. Now, just for comparison, that's out of about 90 million. So we're expecting that by 2050, the total death rate for the world is going to be about 90 million people per year. Now, there's a lot of stuff that we don't know about this. These are the reasons why we're uncertain about exactly what's going to happen, particularly the lack of previous experience. We have not observed this before. We haven't gone through this whole global warming thing with releasing a lot of carbon dioxide in the atmosphere and so on before. So it's not possible to know exactly what's going to happen. We're just making projections. We don't know exactly the human effects, partly because we don't know what human beings are going to do. We don't know what policies we're going to adopt. And also, though, we don't know how well we're going to adapt to changing conditions. So as it gets warmer, maybe human beings will find clever ways to adapt to the increasing temperatures, right? So right now, people are expecting there to be crop failures due to some places becoming less suitable due to being too hot, but maybe human beings will figure out ways to adapt to that. Some people are worried about the flooding, but maybe human beings will adapt to that as well. So we don't know exactly how well we're going to adapt, so we don't know exactly what the harms are going to be. Note that human beings in the future are going to be much wealthier and more advanced if present trends continue. So by the year 2100, we're probably going to have more technology that we can't now imagine. We're going to have discovered some stuff that people today have no idea of. And so there's really, in principle, no way of predicting what the effects of advanced technology might be, and they might help us to adapt to global warming. Okay, now how could we respond to global warming? There are basically 3 kinds of strategies that people have proposed. They're referred to as mitigation, adaptation, and geoengineering. Mitigation is basically trying to reduce our contributions to the greenhouse effect. So one thing we could do is we could convert to vegetarian diets so that there would be less release of methane into the atmosphere. There are many other reasons to do this, particularly the amount of cruelty involved in the meat industry. There are also health reasons for doing this and so on, so that might be worth doing. Electric cars are another thing that we could do. We could move from gasoline power to electric cars, and that would reduce our carbon emissions. We could have less air travel because the airplanes are releasing CO2 and so on. We could also change our sources of electrical power. So we could stop burning so many fossil fuels, especially coal, and we could switch to getting electric power from wind or solar or nuclear sources. These are things that the government might do, laws that they might pass. So they might pass laws limiting the amount of carbon emissions that you're allowed to do. They might do this for automobile emissions. They might do this for industrial applications. Or they might put a carbon tax, or they might do both of these. Might put a tax on emissions of CO2. Also, a really easy, obvious thing that we could do is we could just stop subsidizing the fossil fuel industries. So governments around the world are actually paying the companies that are producing fossil fuels, and it's a total of around $5 trillion per year worldwide that governments are paying in order to actually support the use of fossil fuels that are contributing to the global warming. So that seems kind of crazy. Maybe we should stop doing that. Okay, now the adaptation strategy is, well, we could accept the fact that there's going to be more global warming, and we could just try to adjust to living in a warmer climate. So, for example, we could build dikes and seawalls around coastal cities in order to prevent flooding and then just live with the greater temperature. Okay, now this is not impractical. There are places where that has happened. So most of the Netherlands is actually below sea level. And so they have these dikes and seawalls to protect their country from being flooded. New Orleans is actually slightly below sea level, right? Just a little bit. And similarly, they have technology to prevent themselves from being flooded. We could move farms from areas that become too hot, and we could just farm in other areas that are perhaps presently too cold to farm in, but with the global warming, maybe they'll become warm enough. And we could simply move people away from inhospitable places. So if there's a place that's subject to flooding and it's too expensive to build dikes around it, people could just move to a place that's less likely to flood. Okay, the geoengineering strategy, this is the third and maybe most controversial thing that people have suggested, but some people have suggested that rather than trying to reduce our contributions to the greenhouse effect, we could just develop other technologies that would have the opposite effect and just deploy those to try to cool down the climate. Right, so we could release things into the atmosphere that would reflect more sunlight, or we could just have things on Earth that reflect more sunlight, like we could have more reflective roofs on buildings. We could develop technologies that would remove greenhouse gases from the atmosphere. Now, the advantage of these kinds of geoengineering approaches is they would generally be much cheaper than trying to reduce emissions of carbon dioxide, because actually it's really useful to us. The stuff that we're doing that's releasing CO2 is really useful to us, and it's very expensive to stop doing it. The disadvantage is, we don't know exactly what is going to happen if you do some major engineering project on the Earth's climate. You should worry that there might be unintended consequences because we don't understand everything about how the climate works. And so we might mess up something while we're trying to fix it. Okay, now I'm going to go on to talk about climate skeptics. So there are a number of people who don't like the whole global warming idea and don't believe in it. And so these are the different kinds of skeptics that there are. There are what you might call trend skeptics. These are people who doubt that the Earth is actually warming. Then there are attribution skeptics who accept maybe that the Earth is warming, but they doubt that human beings are a major cause of it. And then third, there are impact skeptics who maybe accept that we're causing global warming, but they're not sure that it's such a bad thing, and they think that it might even be beneficial. Okay, now in the popular discourse, you mostly hear about trend skeptics and attribution skeptics. You don't so much hear about the last two kinds, but the first two kinds of skeptics, I take it, are wrong. The last two are kind of more interesting, and it's not as obvious that they're wrong. Right, so consider, for example, that a lot more people die every year from cold than from heat, right? And it's unlikely that we just happen to be living at what is the optimal temperature for human beings to live at, right? Maybe the optimal temperature for human welfare is actually higher than what it is now, the optimal average temperature for the Earth. And so maybe global warming is a benefit. Right now, of course, we should note that we're presently adjusted. We have adjusted to the existing climate, and so it is likely going to be costly for us to adjust to a warmer climate. But it's not totally stupid to think that the warmer climate might in the long term be more hospitable to people. There are these mitigation skeptics, as I call it. These are people who just doubt that stopping global warming is either feasible or cost effective. Right? In other words, you might agree that global warming is happening and we're contributing a significant amount to it, and also agree that it's bad, but you might think we just really can't stop it, or in order for us to stop it, it would just be so expensive that it's not worth it. Okay, and on the subject of this kind of mitigation skeptic, I mentioned Bjorn Lomborg, who is probably the most well-known example of this. So he's a Danish author who used to be a professor of political science. He's the president right now of a think tank called the Copenhagen Consensus Center. This is a think tank that's devoted to studying the best solutions to global problems. By the way, it is not devoted to studying global warming. It's devoted to studying global problems in general and how we should prioritize them, and what are the most important solutions that we should be devoting resources to, and so on. Okay, and so he's gotten together experts from around the world to help him try to figure out what are the best solutions and what should be our top priorities for the global problems. And what happened when he did this was he just came to the conclusion that global warming is a very low priority. And the reason for this is not that he was skeptical about the existence of global warming, or that we're contributing to it, or that it was going to be harmful. The reason is just that when you look at the methods that people are proposing to stop global warming, it's incredibly expensive to have a really small impact. So we might wind up losing trillions of dollars trying to slow down global warming and wind up only slowing it down by a decade or 2 decades or something like that, right? Or winding up with making a difference of 1/10 of a degree in the year 2100 or something like that. And Lomborg says, well, if we're going to be giving up trillions of dollars, there's actually a lot of good that we could do if we spend those trillions of dollars on things other than global warming. If we're going to spend $1 trillion, we should save like tens of millions of people from malaria and tuberculosis and so on. Okay, and so for this reason, Lomborg is sometimes considered a climate skeptic. So this is Lomborg's view. Again, he thinks global warming is real. It is largely anthropogenic, i.e. caused by human activity, and it will cause significant harms. However, it's not as harmful as the alarmists are claiming. For example, some people are claiming that global warming is going to make Earth uninhabitable. That's false. People worry about coastal cities being flooded and a bunch of people drowning. False. That is not going to happen. Second, he thinks carbon reduction is extremely expensive, and there are many other problems that could be mitigated at a far lower cost. And so global warming is just a low priority. However, he does still support a carbon tax. Okay, now Lomborg has come under criticism from a lot of people, including, for example, Joseph Stiglitz, who is a pretty well-known Nobel Prize-winning economist. So Stiglitz was criticizing Lomborg and arguing that we should really be extra cautious, for one thing, because there isn't another planet that we can move to. So if we're just uncertain about the impacts of global warming, we should really take strong action to try to address it. He also thinks that Lomborg discounts the future too much. So when Lomborg is trying to figure out what are the best priorities, what are the best solutions to global problems, and what should be prioritized, he uses this assumption that a benefit that you get in a year from now is worth less than a benefit that you get today, right? And the amount by which it's worth less is referred to as the discount rate, okay? And so Stiglitz refers to this, and then he talks about how Donald Trump uses a 7% discount rate, so meaning that getting a benefit today is about 7% better than getting an equal-sized benefit a year from now, okay? And when you use that discount rate, then you get the result that stopping global warming is a really low priority, right? And there are immediate problems that we could address right now that come out being higher priorities. Stiglitz also goes on to reject this idea that we should, prioritize other things ahead of global warming by saying you don't have to choose between addressing different problems. We can walk and chew gum at the same time. He actually literally says that. We can walk and chew gum. And similarly, we can address global warming and grow the economy at the same time, right? And so we can also address other global problems. Now, Lomborg has responded to this. He basically denies all of Stiglitz's factual claims. Basically, he says everything Stiglitz is saying about me is false. Um, and he says that he does take account of the risk involved in global warming, and the way that he does this is by taking the expected costs of global warming and then adding 25%, just to be on the safe side, just in case it turns out to be worse than we thought it was. He also says he uses a discount rate of between 3.5 and 5% per year, not 7% like the Trump administration, right? Now, Stiglitz didn't attribute to Lomborg the 7%. He attributed it to Trump, but he talked about it right after criticizing Lomborg. So that kind of might give you the false impression that Lomborg was using this unreasonably high 7% rate, okay? Now, the 3.5 to 5% is pretty normal in this area where people are reasoning about, far future benefits. It's pretty standard to use discount rates in that range, and pretty much everyone who talks about these things, economists in particular, agrees that there should be some non-zero discount rate. Okay. He also says that even though we can walk and chew gum at the same time, we cannot address all global problems at the same time. And the reason for that is that the global problems that we want to fix cost money. And that includes mitigating climate change. The idea that mitigating climate change is just going to be costless, or that it's actually going to be of negative cost, that the stuff that we do to reduce carbon emissions is actually going to grow the economy, is totally not credible, right? It's going to cost, probably hundreds of billions to trillions of dollars, okay? And, if it was actually more economically efficient to not use fossil fuels, we wouldn't be using them. We would not have started using them in the first place. We're not stupid, right? The reason people are using them is that it's cheap. And so it stands to reason it's going to be expensive if we try to stop global warming, right? Okay. Now, these are some philosophical questions that I'd like you all to think about. So the first question is, how much responsibility do individuals have? A lot of the discussion has to do with government policy. What should the government do? Should the government prohibit fossil fuels? Should they create carbon taxes or issue limits on the amount of fossil fuels, et cetera, et cetera? But what about us as individuals? Are we obligated personally to change our lifestyles? For example, are you as an individual obligated to give up air travel because it contributes to the greenhouse effect? Okay, now I'm not going to answer that question. I leave that as something that I'd like you to just think about. And I'd like to note one of the problems here. So the reason why people are not generally changing their lifestyles, or not changing them very much, is probably because it's a public goods problem, which is sort of like a collective version of the prisoner's dilemma problem, right? So the thing is that if you give up air travel, what you're doing is giving a benefit to everyone, giving a benefit to the world, but you bear the cost of your decision, right? Like you're personally bearing 100% of the cost of you giving up air travel, and the benefit of you giving up air travel goes to the world in general. You don't get 100% of the benefit. And so that's basically why people are not doing that. But, you can have a philosophical question about whether we're obligated to do it anyway, right? Even though we're taking all of the cost and getting only a small part of the benefit. Second question, how should we prioritize global warming compared to other problems? And this is related to the question of what's the appropriate discount rate for future costs or benefits. In other words, by how much should we prefer getting a benefit immediately over getting a benefit at some future time, years from now? Now, if you take a zero discount rate, i.e. if you count future benefits as being exactly as good as equal-sized present benefits, then that results in a high priority for global warming. But if you introduce a discount rate of just a few percent, that turns global warming into a very low priority. And the reason for that is that most of the benefits of addressing global warming today would happen in the fairly distant future, like decades from now, even a century from now or more. Whereas other global problems that we could address, like malaria, tuberculosis, malnutrition, and so on, we could save people today. Right? We could save people this year if we devote a lot of resources to that. Now, why do people believe in a discount rate? This is largely because there's a certain rate of economic growth that we're expecting to continue for the next century. And that rate of economic growth means that people a century from now are going to be much better off overall than people today, which means that a century from now, they're going to be much better able to adapt to whatever problems are happening there than we are today. And so it might make sense to devote more of our resources to helping the people who are relatively poor, i.e. the today people, right? Because the today people are poor relative to the people in a century from now, right? And you don't want to redistribute from the poor to the wealthy, so you might think you don't want to redistribute from the present to the future. Since those future people are going to be so well off, we should worry more about the poor and underprivileged today. Okay, the third interesting question is, what is the appropriate government policy with regard to global warming? So we could end subsidies for fossil fuels, as I mentioned on a previous slide. We could also have a carbon tax, and there's a very good rationale for this. So it's that it internalizes externalities, as economists put it. So an externality is an effect that your action has that's either it's a benefit that you don't get rewarded for, or it's a cost that you don't have to pay for. In the case of CO2 emissions, it's a negative externality, i.e. people who are emitting CO2 into the atmosphere are imposing a cost on the rest of the world, and they don't have to pay for it. Introducing a carbon tax would make them have to pay for that cost, which seems fair. If you're creating a cost that you're imposing on others, it seems like you should have to pay, an equivalent amount. It's also economically efficient to make that happen, right? Because if the person who's creating costs doesn't have to pay for them, then they might create costs even though the benefit of the thing that they're doing is smaller than the total cost that it creates, just because they're self-interested. There's also the geoengineering approach, which remains controversial. Another thing that people are proposing is maybe we could subsidize alternative energy. And I'm not going to answer whether we should do those things. I'm just raising this as something that you should think about. The fourth question is, who should bear the costs of addressing global warming? So you might think maybe the countries that contributed the most to global warming should bear most of the cost, like the United States, right? We're the biggest contributor. You might wonder whether developing countries should be able to keep emitting CO2. And so there's going to be a controversy, because countries like the United States are not going to want developing countries to keep emitting CO2. Like, if we have to give up our fossil fuels, we're going to say to the developing world, well, you should give up your fossil fuels too. Because we don't want there to be all of this global warming that's caused by your continuing activities. But the people in the poor countries are going to say, well, you guys can give up fossil fuels now because you've already become wealthy, and you became wealthy largely by using this technology that was releasing CO2 into the atmosphere. So the poorer countries are going to regard it as unfair if they have to give up on CO2 emissions, if they have to give up on, using the cheapest energy sources, which the wealthy countries already did use in their developing phase, right? Okay, the fifth question is an epistemological question. How much should we trust the experts? And this comes up a lot in the global warming area, because there's testimony from experts, like there's sort of a consensus among climate scientists about global warming, but then there are these people who are skeptical of it and who question whether you should even listen to what the majority of climate scientists say. Now, why do people have this controversy? So sometimes the skeptics will point out that experts are sometimes wrong, maybe fairly often. Okay, and that is, in fact, true. So not only are there cases where you can find an individual expert who's wrong, but there are, in fact, cases where you can find the majority of experts have been wrong. Okay, so for example, it used to be thought that fat in general was bad for you, and a majority of medical experts would have said that. We now realize that that's not true, and only some fats are bad for you. And actually, the advice that people were giving, to reduce fats in their diet was actually bad for them. Okay, and there's just stuff like that that happens periodically where the majority of experts are wrong. Now, the obvious response to this, though, is yes, experts are sometimes wrong, but non-experts are wrong more than experts are. So if you're a non-expert, you should still listen to the experts, even though that doesn't guarantee you to be right. It just reduces your probability of being wrong, because if you just listen to yourself, as a non-expert, you're more likely to be wrong. Okay, this is another thing that people say. Sometimes people argue that, it doesn't matter if there's an expert consensus. All that matters is the actual direct scientific evidence. So you should just look at what the evidence is for global warming. You should ignore facts about how many people believe that that evidence shows anthropogenic climate change. So this is a quotation from Michael Crichton, the famous novelist. He says, "Let's be clear. The work of science has nothing whatever to do with consensus. Consensus is the business of politics. Science, on the contrary, requires only one investigator who happens to be right, which means that he or she has results that are verifiable by reference to the real world. In science, consensus is irrelevant. What is relevant is reproducible results. The greatest scientists in history are great precisely because they broke with the consensus." Okay, so he's trying to convince you there that you should not listen to the argument that the majority of climate scientists believe in global warming, and therefore it's probably true. You should not listen to this because that's just not how science works. You should just only look at the objective evidence and not look at how many people believe in a particular opinion. Okay, now the response to this, the best response to this is probably that, well, if you're not an expert, you're probably not going to be very good at assessing the evidence directly, right? By the first order evidence, I mean the evidence directly about the climate, right? Like ice core samples or things like this. If you're not an expert, you probably are not going to be very good at assessing that evidence, and it's going to be easy for you to be misled. And so it's going to be more reliable if you look at second order evidence. And second order evidence is, by that I mean somebody else has looked at the evidence and then you look at what that person says. It's plausible that that would actually be more reliable. Again, if you're not an expert, right? Because the expert is probably going to be better at figuring out what the first order evidence actually supports than you are. Okay, here's the sixth and final philosophical question that I want you to think about. It's how should we deal with uncertainty? And that comes up a lot in the discussion of climate change because, all of this is new to us. We have not gone through this global warming thing before, so we don't know what's going to happen. And there's a lot of uncertainty, and there are different models that have widely varying predictions about, how much the Earth is going to warm, how much the sea level is going to rise, and things like that. Okay, so some people think that we should basically assume the worst just to be on the safe side. And you remember Joseph Stiglitz in his attack on Lomborg, one of his comments was that we don't have another planet that we could move to, right? And so I take this to be kind of invoking what they call the precautionary principle, right? The idea that you should kind of assume the worst, right? Like if there might be something super bad that's going to happen, you should basically act as if that is going to happen, even though it hasn't been proven, right? So the idea is kind of like the burden of proof gets shifted if there's a possibility of an extremely negative consequence, right? Then it becomes that, well, if the extremely negative consequence might happen, then we have to take action as if it was going to happen, unless you can prove that it's not going to happen. So my concluding thoughts, first, I assume that anthropogenic climate change is probably real because that's what the majority of experts think, and I'm not an expert. Now, these are the things that I want you to think about. First, what should individuals do about climate change, if anything? Second, is global warming a high or a low priority? Third, what should the government do about it? Fourth, who should pay the costs of addressing global warming if we try to mitigate it? And fifth, think about whether we should trust the experts if we're not experts. And finally, what should we do if we're uncertain about what's happening and what the effects are going to be?